Today we're going to go over how to simplify and use factorials and counting principle for probability. Factorials means that we are doing the product, multiplying, and it's indicated by an exclamation point. So 3 factorial would look like this with a 3 and an exclamation point on it, which means 3 times 2 times 1, which would be 6. So in example 1, we're going to practice simplifying them. 4 factorial is 4 times 3 times 2 times 1. Which equals 24. 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. 5,040. 1 factorial is just 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And I don't really need the 1 on there. 12 factorial. I write all of the values out in descending order. 6, 5, 4, 3, 1. X 4, 7, 9, 0, 0, 1, 6. Now I have a fraction written over it, so I have 6 factorial on top, 6 times 5 times 4 times 3 times 2 times 1, over 4 factorial, 4 times 3 times 2 times 1. I'm going to cross off everything that they have in common, which means I have 6 times 5 is 30 and nothing on the bottom. 17 factorial over, this is going to look really weird, so 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 2, 1, over 14 factorial, and 3 factorial. I'm going to write this up here. 3 times 2 times 1. So I have to have both the factorials on the bottom. Notice the 14, 13, 12, all of these are going to cancel out, so I'm left with 17 times 16 times 15 over 3 times 2 times 1. I'm going to try and reduce it, so 17 won't factor, 16 is 2 times 8, and 15 is 3 times 5. The reason I do this is because now the 3 will cancel and the 2 will cancel. 1 on the bottom won't affect it, so I can do 17 times 2 canceled out. 8 is there, 3 is gone, times 5 is 680 for 17 factorial over 14 factorial times 3 factorial. The counting principle. Let's just try a problem really quick. So the counting principle, when I have 2 types of body styles, 5 colors available, and 3 models, and wants to know how many choices, I take each option, 2 times 5 times 3, 2 times 5 times 3 for each choice to get my final answer. Now, if I have, so this is another example of one where I would use a factorial instead of the counting. In how many ways can 5 bicycles be parked in a row? So I have 5 bikes, and I'm putting them in 5 parking spots. So when I go into my first spot, all 5 bikes are available to pick from. Now for the next bike that's parking, there are no longer 5 bikes to pick from, there are now 4. Because I've placed a bike. 3, 2, 1. I multiply all of my options together, which is the same as 5 factorial. 5 times 4 times 3 times 2 times 1. There are 120 ways to organize those bikes, to park them. Now, let's say there were 5 bikes, but there were only 3 spots available. Then I would have 5 bikes available for the first. 4 bikes could go to the second. And then I'd have 3 left over to pick from for that last spot, and the 2 other bikes would not get a spot. They would be left out because there aren't enough places for them. And this is just a what if question. It wasn't part of it. Let's try.